boys and girls, the problem set for lesson 2, these first 3 are actually the ones we did yesterday. Okay? So the directions say, what, Autrey? Read those to us.
Shade the following figures on the centimeter grid paper. Cut and fold each to make 3 open boxes, taping them so they hold their shapes. Pack each box with cubes. Write how many cubes fill each box.
Okay, a lot of you are going to remember how many cubes filled each box. So let's take a look at this first one. Do you remember that first one we made?
Yeah.
How many cubes was it?
8.
Good. So just write 8 centimeters cubed. Okay. What multiplication problem did you do to figure that out? I'm just curious.
4 times 2.
4 times 2. So we could write 4 cubes. You don't have to, but we will later. Times 2 equals 8 cubes. That's our thinking. Okay? Now, the next one. Let me pull a stick and see if this person. So, Lynn, do you remember how many were in figure B?
18.
You're close.
16.
So let's do this. 2, 4, 6, 8. 8 times 2.
8 times 2 is 16.
Good. So 16 cubic centimeters. And what problem did we just do to figure that one out?
8 times 2.
8 cubes.
8 cubes times 2.
Good. Equals 16 cubes. All right. Now the last one, we didn't actually cut it out. We just shaded it, and then we did the first layer right here and took it times what? How high is
Times
this one?
3.
Times 3. So this first layer, let me pull a stick. Addison, what is that first, the base actually? 16. So 16 cubes times 3 equals, do you remember what that was? 48 cubes. Very good. So 48 cubic centimeters. Okay, so those of you who are writing all that, thank you. Those of you who are playing with your shapes and all that, stop. Okay, let's take a look at number 2. So this is about where I started messing up on my pausing and recording. Okay. It says, predict how many centimeter cubes will fit in each box and briefly explain your predictions. Use, just a minute, use cubes to find the actual volume. Okay. So our prediction, let me pull a stick, is, Samaja, what do you think this is right here?
8.
8. So we're going to say 8 cubic centimeters. How'd you get 8, Samaja?
Because
There's 2 rows of
4.
4. So, you know how it says briefly explain?
Yeah.
I'll let you write that math problem. So you can write 4 cubes times 2 equals 8 cubes. Now, what I want you to do is build it to check the prediction. Kevin, was the prediction of 8 cubic centimeters correct?
Yeah.
Okay, so let's move on to the next page. Go ahead and fill that in, boys and girls. Okay, same thing again, just a different rectangular prism. Eyes on B. Okay, a prediction, Jocelyn, for how many cubes are in this figure?
16.
Okay, how'd you get 16?
There's 4 rows of.
So there's 4 and 4, which is what? 8. And how far back does it go? 2. So could we write 8 cubes times 2 equals 16 cubes? Okay, now I want you to build it
Oh.
to check Jocelyn's prediction. So was Jocelyn's prediction correct?
Yeah.
Okay, 16 cubic centimeters. The next one, I'm going to pull a stick. Autrey, what do you think it is?
40.
You think it's 40. How'd you come up with 40?
Because the first one has 20.
Okay, what do you mean by the first one? The front. The front of it has 20 cubes. Okay, are you writing this, boys and girls?
Yeah.
And then how far back does it go, Autrey?
2.
2. So we're going to double 20. And so it will be 40 cubes. Okay, check it please. So for those of you who had enough cubes to build it, was the prediction correct?
Yes.
Okay, go ahead and fill that in. Okay, move your cubes back, just slide them back. And I need you to do that quickly, right now. Okay, so your net. Your net looks like this. How many boxes are on your net?
Where's the line?
6.
6, okay? And what do you think that, now just think about it, or does it say it on the board? What do you think that would look like if you cut it out and fold it up?
A cube.
A cube. Does it say that? Sure does. So what I want you to do right now with your net is to cut it out and fold it up. And then we're going to talk about some other nets. So both of these nets fold into a cube, don't they? Okay? How are they different?
Because that one doesn't.
Okay, the blue one,
Doesn't have the top yet.
the two on the side are in a different place than the purple one, correct? Okay? Well, how many sides does a cube have?
4.
Really? 6. Aren't there 6 numbers on a dice?
Yeah.
Okay. So there are 6 sides. The characteristic of a net of this cube is going to have 6 sections in it. Okay? They can be in different places though. So if I fold this one up, I'll fold the sides in and then curl it up. It makes a cube. Okay? So these two right here are the top and the bottom. Right here, the ones I'm touching. Okay? Those are the top and the bottom. On this one, look at this.
Those ones inside.
Top and bottom again. That's what I like to think of it as. And the reason I like to think of it as that is because this is the base and the top. And so you know what the shape of your figure is going, your 3D figure is going to be by looking at these two that are out on the side. Okay? Now what if I move this one down here? Would it still work?
Yeah.
It would. Because if I fold it, it doesn't matter which direction I fold it. I can fold it from this side, or this side, and it's still going to fold, isn't it? Okay? So how is the cube different from the rectangular prism? Well, it doesn't necessarily have to be bigger, but I sort of drew a rectangular prism up there, not a cube. They're rectangles. They're not squares, okay? So here's your base, here's your top, and these are your sides. Of course, you could turn it over like that, couldn't you? But I want to think about bases, all right? So there's a rectangular prism. Now, this shape right here is a what? Hexagon. So what do you think this one's called?
Prime. Prism.
It's a prism still, because the base and the top are the same. Hexagonal prism, okay? So could this hexagon be anywhere? As long as they're on opposite sides. And how many sides are on a hexagon? How many sides are on a hexagon? 6. 1, 2, 3, 4, 5, 6. That's how many will be in the middle, okay? So this is, what kind of prism do you think this is?
A triangle prism.
Triangular. Okay. And what are the base and the top shaped like? Triangles. Okay. How many sides are on a triangle?
3.
I wonder if I have 3 here. Very cool, isn't it? Okay. Now this shape's different. My base is actually a rectangle.
A pyramid.
It's a pyramid. So this is called a rectangular pyramid. Okay. How many sides does a rectangle have? 1, 2, 3, 4. Okay. Here's my base. This one is also a pyramid, but it's not a rectangular pyramid.
The triangular.
Triangular. Good job. So triangular pyramid has a base that is a triangle, and it folds up into a pyramid. Okay. We usually call this a cylinder, don't we?
Yeah.
And you learned that when you were younger. The cylinder is going to have 2 circles, and they're going to have to. They have to be opposite each other. They just have to be on opposite sides. One more. What's this called?
A cone.
A cone. A cone. The cone.
Looks like a person. What the?
Okay, I don't care what it looks like. I'm showing you what it looks like when it's flat. You're going to predict the number of 1 centimeter cubes that will be required to fill the net you just made. The cube you just made. I'm going to pull sticks, okay?
For now.
Jasmine, what do you, now you can't, it's not really wrong because it's a prediction. So it's okay if you don't get it right. But I just want you to predict it. Give me a number. Okay, that's a good prediction. All right. So now how do we check this prediction? We fill it up.
Do it.
So anybody have a different prediction?
Me.
Gavin?
27.
Yeah,
Yes.
that's right.
Who else said 27? Okay, let's see if they're right. Okay, Farrah, tell me how you came up with 27.
Because the other cube that we made yesterday was it was only 2 wide, and this one at the bottom is wider than that.
So you thought, okay, based on the size of yesterday's cube, mine's going to be 3 wide.
Yeah.
Okay, so I'm just going to put this cube will be 3 wide. Better put 3 cubes wide, right? Okay. What was your next thought, Farrah?
And so if there were 3 rows of 3, then it'd be 9.
Okay,
And then
so
since it was 3 wide, then it'd be 3 tall.
3 rows of 3
Multiply 9 by 3.
would be 9. And in order to be a cube, would we have to have 3 again?
Yeah.
Okay?
Yep.
So to make a cube, it needs to be 3 tall, right?
Yep.
So 9 cubes times 3 times 3 equals 27 cubes. Very good. And was Farrah's prediction accurate?
Yes.
Actually, I should have written that down there, shouldn't I?
Yes.
Yes, my prediction. So then, did you have a question?
I was gonna ask his chapter. I mean, like.
Okay. Okay, boys and girls, take a look at the exit ticket. I'm pretty sure this first one, this first figure, is one from yesterday. The only thing I'm going to remind you is all of these need labels.
CM3.
Cubed. Okay? So all you have to do is count up here or figure it out. Number 2, you need to predict how many centimeter cubes will fit in this box shown and explain your prediction. Somebody tell me how we've been explaining predictions today.
Using.
Gavin?
You did a multiplication system.
I just do a multiplication problem, but I'm using the word cubes in it. So that's going to help you. Boys and girls, you may not believe this, but kids have been counting these incorrectly. I heard the word 16 for this one. This is the first one we did yesterday.
Wait, what?
So use it, okay? Use those shapes from yesterday.